Thanks for joining me for part 6 of hand-laid dual gauge turnout in any scale. It's come time for us to remove the ON30, ON48 dual gauge turnout from the template. What we need to do is we need to fashion some spacers to hold the rails approximately engaged. Now, because I've not attached them to ties, when we transfer it over to the road bed and to our ties, we'll be able to make final adjustments on gauge at that time. But for now, we just want to keep everything in rough approximation. The first thing that we want to take note of is this frog and this frog can either alternately be the right rail going this direction or the left rail going this direction. That means that the polarity of that frog changes depending on how we're going to throw the frog. So what we're going to have to do is we're going to have to electrically isolate this frog, and it's too long to support short wheelbase locomotives, so we're going to have to supply some alternating electrical power to this frog. So that means we've got to have it isolated. And if you look carefully, you can see that on the template that Fast Tracks has made provision for that here, and they've highlighted these two darker ties. What we'll do is we'll cut the frog between those two ties. Then as we move down here, there's another area where there's two ties adjacent to each other, and we'll cut the frog there. I'm just going to use some scrap brass rail I've salvaged from some very old sectional track. I've taken it off, I've straightened it as best I can. And now what I want to do is just kind of prep it a little before we trim it to the lengths we need. The first thing is I want to remove this decades of oxidation from the underneath side of this rail. So I'll just get my rail cleaner and I'm going to give it a good little scrub until I see fresh brass. We'll do it to the other one as well. I don't know exactly where these rails are going to fall on top of our turnout. And I don't really want to spend time individually dabbing flux onto it. So before I even trim them to length, I'm going to take just a bigger, older, cruder brush. I'm just going to spread flux paste on the whole underneath side of this rail. Now it'll be ready for us when we're ready to cut it to length and use it. Again, for this rail, just a whole bunch of flux paste along the length of the bottom of the rail. With that done, we can now start to trim the rail to length. So for this first section, where we're going to have the cut that isolates the frog, I'm going to trim one for here. I'll trim one for here. We're going to trim one for up here. Another for up here. We gotta have a few more. Fast Tracks is going to have us put a couple here, one here. That's if you were soldering it to your ties. I think we'll just go ahead and kind of follow their lead there. I've got one long one here left over from earlier in the project. I've got some shorter ones that are going to go out on the tails of the rail. I've got another one here. I'm going to put it up by the points. So let's go ahead and cut a couple more to be secured at a couple other spots along this project. Oh, I think about there should do nicely. I haven't placed them on everywhere that Fast Tracks wants them, but enough. So now I'm going to get my solder. I don't want to put them over the rails or over the points where we have secured the rail to the template with spikes, so I want to be a little careful there. So I think we're going to put one here, here. I'm going to try and not do the point rails. I'm just going to do the stock rails. Put a little flux paste on it. Position the rail there. I'll now heat the rail with my soldering iron. Give it a chance to warm everything up. Remember, I don't want to melt my solder on the soldering iron itself. I want to do it on the metal. There's a lot of metal here. We may get heat conducted away fairly briskly, but let's see what we get. One little spot there. This might be where a higher wattage iron would be a good idea. With a little wood block to hold it down. Make sure it's in contact. Come over to this next joint again, warm that one back up, get it to flow. I can see it's flowing. Hold it in contact, remove the heat, let it solidify. Come to this through route stock rail, get it warm. Let it liquefy, hold it down tightly. Good. So those are connected quite securely. I'm going to go ahead and just repeat this process for the remainder. And there we go. The turnout is now free. It's at this point that we can turn the turnout over. We can clean up the bottom of these joints and reinforce them if we want to. The real important reason is we're going to need to have access to the underside of the points in order to do the next step, which is to position the connecting and throw bars. With the turnout turned upside down, I've got an opportunity to just clean up the bottom a little bit. Okay, filing the solder blobs flat will assure that the turnout lays flat and true on our ties when we're ready for that. For the next step, we're going to start to work on the connecting rod and throw rod bars. Okay, let's look at a couple of techniques for making the throw bar or front tie bar. And the first one I'm going to do is the way that Fast Tracks does it. And we need to do a couple things first. We have the turnout turned upside down, and I've got it supported. I've got the points and the stock rails supported on a piece of wood here. So what I want to do now is I just want to make sure that the bottom of these rails are dressed, filed smooth, it's all clean, things are good. So a little bit of work there to make sure everything is smooth. The next thing I want to do is make sure that the surfaces of the points and notches are all clean. So I'll inspect those, and I like to just set the file between the point rail and the stock rail. Apply just a little pressure and just give it a little touch up. Now, if I do this right, I'm kind of preparing both sides of that notch. With that done, the next thing I need to think about is keeping the solder off of the stock rails when we start to solder the tie bar to the points. So what I'm going to do is I'm going to just spread that point rail out a little bit. I'm going to put a little piece of masking tape on the inside of the notch. I just want to do a little bit of pre-tinning of the underneath side, the base side of those points. With the rail tinned, now what I want to do is I'm going to turn it back over. I'm going to put some PC board tie into this little jig I've created here just to hold it still. I don't know how wide, I don't know which side I want the throw for this turnout to be on. So I'm going to be generous and leave quite a bit of tie on either side. So I'll position it about there. The first one that I'm going to do, let's see, we need to tin this up a little bit. Let's go ahead and do that. All right. With the turnout in position, angle to the throw bar for this main rail on the outside, common rail on the outside. Bring this over a little bit, and I'm just going to give it a little touch. A little touch to get that point soldered in. You see everything has flowed nicely. Let it cool. And now a little test. That point moves fairly freely. Good. Okay, now I want to come over here. I want to do the narrow gauge. We could do this a couple ways. We can somehow secure the common rail, point rail, in the notch, like I'm doing here with this forcep, and just hold it there. Then we can come out here with our gauge and find the width we want for that flange way. Hold it there and solder it down. I think that's what I'm going to do. With a PC board tie, if you get it too hot, the copper wafer on the fiber board inside will delaminate and it won't hold. So you have to just do your solder one time. Try to avoid excessive heat. I'm going to now come over to the standard gauge point rail. Get it into gauge for my flange way width. Hold it tightly down. Get some heat on it. Good. I'll release this forcep. I'll just hold the rails in place. And hopefully you can see the throw of the points. I can then trim the throw bar to whatever length I need. In this next technique, we're not going to solder at all on the top side of the turnout. What we're going to do is we're going to use some fine brass wire to make a hinge joint on the PC board tie. So the first thing I want to do is I want to begin by drilling a hole through the base of the rail and the PC board tie. With a hole now drilled in the base of the point rail, I'm going to drill a hole in my PC board tie. The hole that I've drilled can accommodate the brass rod I have on hand. So now here's what I want to sleep. I'm going to make a small right angle bend on the end of this wire. I'm now going to thread the wire through that hole I drilled in the base of the point rail. and I'm going to pull it until that angle in the rod is at the base of the point rail. Good, there it is. Now what I'm going to do is I'm going to thread the rod through the PC board. And now, with the rod threaded through the PC board, I'm going to solder. And I can see that I now have a connection on that point rail to the throw bar. I'm now going to trim this off. And let's turn this turnout over. And you can see that now that brass rod is acting like a hook or a hinge that the point rail can rotate on. This is nice because you're not going to get any bind with the rail. Okay, I've done that. Now let's take a look and see how that point might work. We've got a little bit of interference from the tape here. And this angle is long enough that it interferes with the narrow gauge rail. There we go. Now we've got a mobile joint on the rail. For this third one, I've done most of the work off camera. Let me show you what I've done. The first thing I did was I cut a few pads of PC board tie, and I did it the width of the point rail plus the width of the stock rail plus the width of the flange plus a little bit extra, and that came, for my scale, out to be 200 thousandths of an inch. I cut two of them that width and then one a little longer, 2500 thousandths of an inch. I then soldered those tabs to the point rails, and I did it so that the overhang would rest under the stock rail. Now this provides a float, a support for that rail as it moves back and forth. Over here on the standard gauge rail, the float went out to the other side. So I did that. Then what I did is I pre-tinned the opposite side of those PC board tabs. I secured the first one over on the common rail. I then took a piece of PC board and I used it as a rough spacer for my flangeway, since it's just a little wider than the flangeway I wanted. Then what I did is I pulled the rail over to that and soldered this pad. With those two in place, I then took my PC board spacer, I put it between the standard gauge stock rail and point rail. I pulled the narrow gauge point rail over to a point where it was in gauge and it was touching, and then I soldered the pad on the bar. So now what I have is I have 3 pads that secure the rail to the bar, and they are the insulator. The fiber of the tie is the insulator. So now what happens is when this sits in the ties, that rod looks like it is the throw rod for the points. I can trim this to length on either side, and that's the idea I'm going to go with. What I'll then do, one final thing, I'm going to take my pin vise and on this little bit of extra width on the narrow gauge tab, that's where I'm going to drill my hole for my switch machine piano wire throw arm, and that'll go there. We may end up with a little surprise, but I think that this will work well. I know this has been probably the roughest video, a little clumsy. This is a technique that you'll have to have a lot of practice with. Any of these throw bar techniques are going to be one that you're going to have to practice with. Thanks for joining me for this edition